of course, wrong DNS. NS servers are used by networks and their clients to resolve a computer's hostname to its IP address and to enable clients to find the server they need to provide the resources they require, like a domain controller during the login and authentication process. Most of the time, DNS addresses are automatically configured by a DHCP server, but sometimes these addresses are statically configured instead because lots of applications rely on hostname resolution. A botched DNS configuration usually causes a computer's network applications to fail, just like the user's applications in our example scenario. Wrong subnet mask. When network devices look at an IP address configuration, they see a combination of the IP address and the subnet mask. The device uses a subnet mask to establish which part of the address represents the network address and which part represents the host address. So clearly, a subnet mask that is configured wrong has the same nasty effect as a wrong IP address configuration does on communications. Again, a subnet mask is generally configured by the DHCP server. If you're going to enter it manually, make sure the subnet mask is tight or you'll end up tangling with the fallout caused by the entire address's misconfiguration. Incorrect interface, incorrect misconfiguration. If a host is plugged into a misconfigured switch port or it's plugged into the wrong switch port that's configured for the wrong VLAN, the host won't function correctly. Make sure the speed, duplex and correct Ethernet cable is used. Get any of that wrong and either you'll get the interface errors on the host and switch port, or worse, things just won't work at all. Duplicate MAC addresses. There should never be duplicate MAC addresses in your environment. Each interface vendor is issued an organizational unique identifier OUI, which will match on all interfaces produced by that vendor, and then the vendor is responsible for ensuring unique MAC addresses. That means duplicate MAC addresses usually indicate a MAC spoofing attack in which some malicious individual changes their MAC address, which can be done quietly in the properties of the NIC. Expired IP address. In almost all cases, when DHCP is used to allocate to devices, the configuration is supplied to a DHCP client is on a temporary basis. The lease period is configurable. Alright now. Oh, sorry, I'm back. Expired IP address. In almost all cases, when DHCP is used to allocate IP configurations to the devices, the configuration is supplied to the DHCP client is on a temporary basis. The lease period is configurable and when the lease period and a grace period transpire, the lease is expired. The effect of an expired lease is the next time that client computer starts, it must enter the initialization state and obtain new TCP IP configuration information from a DHCP server. There is nothing, however, to prevent the client from obtaining a new lease from the same IP address. Rogue DHCP server. Dynamic Host Configuration Protocol DHCP is used to automate the process of assigning IP configurations to hosts. When configured properly, it reduces administrative overload, reduces the human error inherent in manual assignment, and enhances device mobility, but it introduces a vulnerability that, when leveraged by a malicious individual, can result in an inability of hosts to communicate, constituting a DOS attack and peer-to-peer attacks. When the illegitimate DHCP server, called a rogue DHCP server, is introduced to the network, unsuspecting hosts may accept DHCP offer packets from the illegitimate DHCP server rather than the legitimate DHCP server. When this occurs, the rogue DHCP server will not only issue the host an incorrect IP address, subnet mask, and the default gateway address, which makes a peer-to-peer attack possible, it can also issue an incorrect DNS server address, which will lead to the host relying on the attacker's DNS server for the IP addresses of websites such as major banks that lead to phishing attacks. An example of how this can occur is shown in figure 19.4. In figure 19.4, after receiving an incorrect IP address, subnet mask, default gateway, and DNS server address, the rogue DHCP server and DHCP client use the attacker's DNS server to obtain the IP address of his bank. This leads the client to unwittingly connect to the attacker's copy of the bank's website. When the client enters his credentials to log in, the attacker now has the client's bank credentials and can proceed to empty out his account. Untrusted SSL Certificate. Reception of an untrusted SSL certificate error message can be for several reasons. In figure 19.5, the possible reasons for the warning messages are shown. The first reason, the security certificate presented by the website was not issued by the Trusted Certificate Authority, means the CA that issued the certificate is not trusted by the local machine. This will occur if the certificate on the CA that issued the certificate is not found in the trusted root certification authorities folder on the local machine. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.